here on 16 we're looking at the inverse Laplace. And for the inverse Laplace you want to look for these shifts. This s minus 4 means that I've shifted 4 units, and it means that if I write this in terms of inverse Laplace, the inverse Laplace of f of s minus a is equal to e to the at times f of t. Okay, so what I'm looking for is this f of t, and I know that because I've got this shift of 4 units that my a is 4, and that automatically gives me an e to the 4t. But what I need to look up is the inverse Laplace of 1 over s to the 6th. So if you take that shift away, then what function are you left with? And how do you find the inverse Laplace of that? Well, 1 over s to the 6th, I want to use this definition, where n is 5. That'll give me an s to the 6th in the denominator. And I need a 5 factorial in the numerator. There it is. Okay, so I need a 5 factorial in the numerator, which means I need to divide by 5 factorial in front. And 5 factorial is 5 times 4 times 3 times 2 times 1. Let's see, that's 20 times 6 is 120. So that's going to give me 1 over 120 times the inverse Laplace of, I'll keep that as 5 factorial so it looks like the formula here. And that'll give me 1/20th times the inverse Laplace of 5 factorial over s to the 6th is t to the 5th power. T to the 5th power. And that comes up here and gets multiplied by the e to the 4t. So times 1 over 120 t to the 5th. And that probably looks better if you put the 1 over 120 t to the 5th in front of the exponential function.